All right, so here we go. So we're going to be on 12.1. And if you've already seen some exponents, hopefully this is like, oh, I've seen some of that. That's where we're going to start is rules for exponents. My goal was to at least get to probably 12.4, and then we'll finish chapter 12 on Monday and then get into 13 on Wednesday. Anything that doesn't finish after that, I'll make some extra videos for y'all, push them out to Blackboard. And again, all chapter 12 and 13 is due next Sunday. So you got 2 weeks to do these sets of assignments. Yeah. Go ahead and start it now. So then you can come and really what'd be nice if y'all like went ahead and started the homeworks prior to the lesson, because then you could be like, all right, so this is what they're trying to say. And then you have more specific questions going, all right, I kind of get this. See, the fact that you are doing multiple 8-week courses, that's rough, especially if you're working full time too. Yeah. I did. Audio on. Testing, testing. Right? Yeah. Oops. Should be good. Testing, testing. Yeah, turning green. Yeah. Yeah. There was one time I tried to record and it did not. I think that was like 9.7 or something like that. So it just was notes because I just I forgot to hit the record button. All right, so we're going to kind of just kind of go into these. So we're going to use the product rule for exponents. So here are your main rules to pick up. If you are multiplying like bases, meaning that this guy and this guy are exactly the same, then all you do with these exponents right here are add them. So this answer would be x m plus n. So as long as these guys are the same, you just add the exponents. All right, the next one is if you are dividing like bases, again, meaning that these values are the same, then you're just going to subtract these exponents. So in this case, the answer would be whatever m minus n is. Go ahead. You're multiplying. So if yeah. So but as long as they're the same number, the number would remain the same. So yeah. So for example, let's say this was 2 squared times 2 cubed, right? These guys are the same, so it will remain the same. But since I'm multiplying, I'll add these two numbers. So this will become 2 plus 3, which is 5. Yeah, you don't actually physically multiply the bases. Well, you add the exponents. Okay. Yeah. Yeah. Okay, so no. So in this case, like I said, well, we're multiplying like bases regardless of the numbers or letters. The number of the letter will remain the same. And all I have to do out mathematically is add the exponents. So I'm just going to say 2 plus 3. And the 2 just stays. So you don't actually physically multiply as long as the bases are the same. Correct. So in this case, if I had an example of 2 cubed over, well, let's do this one. I like this one. 2. This is a big one. There's no exponent there, right? So if there's no exponent, there's actually like an imaginary 1 there. We just don't write it. So in this case, this would be 2 because the base doesn't change. And we would just say 3 minus 1. And in this case, it would be 2 squared. Right? So mathematically, if you're multiplying, you're going to add. If you're dividing, you're just going to subtract. And that, well, number wise, then you would express this. What is 2 to the 5th power? What is 2 to the 2nd power? And we'll see some of those, but really we're going to play with letters too. Yeah, so in your calculator, you would figure out what 2 to the 5th power is, which theoretically is 2 times 2 times 2 times 2 times 2. So in this situation, that would be 2, 4, 8, 16, 32. Yeah. And then this one here would just be 2 times 2, which is 4. So with numbers, you would write it all out. Now with y'all's calculators, y'all can just raise it up to whatever exponent it is or anything, and then it'll pop out the same answer. By the way, you can use any calculator, graphic calculator, so Inspire 84, whatever you like. Just no cell phone. That's the only thing. Yeah, yeah. And I have a calculator built in the test. I just don't, it doesn't tell me what it looks like. So did it look like a for function? I said graphing on it. Did it graph? Yeah. Yeah, that's something that the program does. We good there? I'm not going to erase it. I'm just, yeah. So like for instance, on your, so I'll show you with my Inspire, it's kind of similar to your 84. Now, those things do a lot more than I know. So, so when I'm working here, in an 84, you would have just a regular old calculator screen. Granted, it won't have color, it'd be green or black or whatever the color screen is. But what it is I would hit the two still, and you'll have an icon that looks like, I think computer science majors call it a caret. It looks like a rooftop to me. So that's the button you would hit, and then it makes the little box here, and then I can just hit 5, and it just shoots out the answer. Mm-hmm. So next to the X2, it looks like a rooftop. It's called a caret, but it doesn't look like a carrot to me. Hmm? Did you get it? Oh, okay. Gotcha. Yeah. The textbook uses the 84, so there's a lot of directions in the book with the 84. I don't have an 84 anymore. The updated software is an Inspire, so that's kind of what I teach off of. So regardless of which one you have, that's what you. But yeah, so then you would just evaluate it that way. All right, so there is a third rule, and this one is if I have x to the m and I raise that to the n. So this is called a power to a power. You're actually going to multiply these two numbers. So this becomes x m times n. So if you have something that's a power raised to another power, which can happen, you'll multiply the exponents. But notice as well, the x stays x. I don't raise that to anything. It stays the same. You just deal with the exponents. Okay with that? Let's do some examples. So in this example, we'll have x cubed times x squared. In this situation, what would I do with the exponents? Well, I'll keep the base the same. So it'll still be x, and I would add them. So if I'm multiplying, I'm going to add 3 plus 2. Correct. That's it. So the key here is just knowing, all right, if I multiply, I add the exponents. You just got to know the rules. Multiply, add, divide, subtract, power to power, multiply. There's more rules than that, but these are our 3 basic rules. Yeah, so it'll be like you'll have something like in this, and then in parentheses, it'll be raised something. So an example here, and we're going to see one here in a second, but I could have like x squared raised to the third power. So then this answer would be x 2 times 3, which is now x to the 6th. Yeah. So that's what it would typically look like. It can get more complicated, but that's where we'll start. Good? All right. Let's see. B, this will be y to the 5th times y to the 4th. Mm-hmm. That's it. Y to the 9th, because I would just add the exponents. We good? So the wait, oh, like the type to answer? Oh, there's going to be an icon that looks like this. you would hit that icon and then you'd be able to type a Y and then scroll over and hit the 9. Yeah, it wants yeah. So when you're doing your stuff in the online homework, it just wants the answer. Yeah, it's assuming if you can get to the answer, you're doing the work. I mean, to get there. So that's the assumption. This is true. It does make a out of you and me. All right. So here's another one with numbers. 5 squared times 5. There you go. So again, there's like an imaginary 1 right here. So when we add these two up, we get 5 to the third. I was just going to see on y'all's homework, does it make you actually write out the answer? Yes, it does. So with numbers, then you would need to figure out what 5 cubed is. So if you want, go ahead and practice on your calculator and see if you can figure out what 5 cubed is. I got you. 5 cubed. So this would be like 5 times 5 times 5. Oh, that's what a 5 to the third power. It's a cube. But yeah, you don't have to know that. But sorry. Cube is a third power. A square is a second power. And then usually after that, we'll say fourth power, fifth power, sixth power. There's more words for that, but square and cube is typically some words you might see in the book. But yeah, but that 3 is the same thing as a cube. Yeah. And then we have more words like quartic and quintic and stuff like that, but you don't really see that in textbooks. Usually you see fourth degree, fifth degree, sixth degree, and so on and so on. Mm-hmm. All right, let's see how you do on this one. 3 squared times 3 cubed. There it is. So then what would be 3 to the 5th power? Take your word for it, because 2, 3, 9, 27, 81. Yeah, that sounds about right. 81 plus 81 is 162, 160. Yep, 243. Yep, so I did 2 plus 3 and I got 5. And then from here, this is the same thing as 3 times 3 times 3 times 3 times 3, which is 243. This right here would be the answer you would type in. I'm just doing this part to explain what 3 to the 5th power means. Then 3 times 27, then 3 times 81, and so okay. Yeah. Well, so powers were a shorthand for multiplication. Nobody wants to write 3 times 3 times 3 times 3 when we could just say, oh, just 3 to the 5th, right? Mathematicians are lazy. We're going to come up with different ways to shorten the amount of stuff we have to write down. Just like multiplication actually came out of addition. Instead of saying 3 plus 3 plus 3, we can just say 3 times 3, right? So that's kind of where multiplication and the next exponent is a shorthand of that. Unless So let's do one more in this situation. So part E, -3 to the 5th power times -3 to the 2nd power. All right. Yeah, so you're still multiplying. So parentheses and parentheses is multiplication. So I'm going to add those exponents. When you do get to the 7th, what do we get? I can't do that one in my head. 2187. Now, when you typed it in your calculator, did you write it with parentheses and a -3 with a 7 on the outside? Mm-hmm. Yeah, because the -3 is the same as the -3. So the bases are the same. So I just rewrote the base because that doesn't change. The only thing mathematically I have to do is add the exponent. So 5 plus 2 gives me the 7. Seven different times would give you -2,187. Did that work? Yes. Yeah. But I will say that will probably happen on the homework. And you're like, I thought I did it right. And you're like, I forgot the negative. So, yeah. Hey, no problem. We good with that? Okay. Let's look at other situations that you're going to be dealt with. So, number 2, part A, 4 times y cubed times 5 y sixth. Here's where we take a simple concept and now we take it a little bit further. For starters, notice the 4 and the 5 do not have exponents. So you will actually take the 4 times the 5. And what is 4 times 5? Be 20. Now we will apply the product or the product rule that we just learned. Y cubed and y6. It's being multiplied. What would that give me? Y ninth, right? So the base won't change. So it'll be a y raised to the ninth. Now here's the next misconception students will try to make. You'll try to apply the 9 to the 20. That is not the case. The 9 is attached to the y only. So there's your answer. Don't try to figure out what 20 to the ninth power is. Yeah, you still add the exponents. That rule doesn't change. The only thing it brought back in was actually multiplying the numbers. Okay. So taking something we learned, I think in chapter 9, blending it in with chapter 12 now. So that's a lot of that will happen. They give you a new concept, and then now let's blend it with old concepts and make the what seems simple more complicated. Yeah. Yes. You're good? Nope, you'll only be tested over chapter 12 and 13. However, your final will be over all 7 chapters 9, 10, 12, 13, 14, 15, and 16. You won't actually have a test specifically over 16 because that content will be shown after the test, but it will show up on the final. All right. But it is cumulative over all 7. But each unit test we have is just going to be over the 2 chapters for the each 2 weeks that we cover it. Yeah. So yeah. So when you are studying, again, it'll be another open note because you'll be home when you take the test. Just focus on those 2 chapters. You don't have to go like all. Now, granted, there is some things we learn in 9 and 10, like solving equations, that might come up on solving polynomials. Yeah. Chapter 9 on the literal equations that you'll have to do was a tough one. And then in chapter 10, the inequalities look like to be a tough one. Yeah. Yeah. Like I said, when I went back and because I hadn't put grades in until this past Monday, and I was like, oh, he's doing work. I was so thrown off because I was like, oh, because I saw you like logged in like the very first day, and I never saw it again. I was like, oh, he must have looked at it and goes, nope, I'm done with this course. I'm the yeah. But then when I saw you were doing work, and then I saw you message me, I was like, I don't think he realizes this is a face to face. Let me go ahead and let him know. Because I had asked about you the first day because I saw that you were there and yeah. And so I was like, well, maybe he'll show up Wednesday or something. And then you didn't come. I was like, and I didn't see you log back in. And I was like, the 27th of October? Yeah. 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 I will say too, even though the assignments are past due now, you can still go to them as a review for stuff like when you're studying for the final and things like that. So, and even if you did master them and stuff, you can still review it and look at it. It doesn't like rescore it or anything. You still get your 80 or higher that you needed. Um, mhm. Yeah, they count as zeros, but they're about half a point a piece. So if you didn't do like four of them, you only theoretically lost 2 points of your overall grade. The homework, yes, is 30% of your grade, but there's so many of them that it doesn't, each one doesn't hold a lot of weight. Now, if you go and you miss 10 of them, well, now you miss 5 points of your overall grade, and that can hurt because you have to make a 75 or higher to be able to get the credit to move on and still make a 50 or higher on the final. Pending that the average is higher than a 75 is the only chance that you get to do a retake. But I've taught for about 12 years now for remedial purposes, and I've never seen anyone make less than a 50 and still average a 75 or higher. Normally, if you're averaging 75 or higher, you're going to make a 50 or higher and you're good to go. You do. You got a lot of catching up to do. But what's nice is part of my syllabus is the final exam does replace one of the test grades. So the test that you missed, that will be the one that's going to get replaced. So it shows, yeah, it shows up like a zero, but it's going to eventually, you just know in the back of your head, okay, if I make like an 80, I'm still good. Like I'm not in the water. Now you bomb the next one. Now you want to contemplate, okay, now there's only one test and I only get to replace one of them. So yeah. Yeah, absolutely. Yeah, yeah. Yeah. That's what I like about the program. It's AI built. So like you get that immediate feedback. Like, hey, you did this wrong. Here's the step by step on how to do it. And you go, I forgot to carry a negative. I forgot to, or maybe you just might not know anything. You're like, oh, that's the steps. And then you write that out as well. So and they usually when you ask for another one, they give you like a very similar question. They just make it a five instead of a six or something. Yeah. Yeah. All right. So let's look at another one. In this case, that would be negative 2x to the fourth times 5x cubed. What is y'all's thought process here? Letter. Mm-hmm. Okay. Very good. Perfect. Good. So that would give you x to the seventh. And then now multiply the actual coefficient. So negative 2 times 5 would be negative 10. It's a negative. No, that's a positive 5. If it would have been a negative 5, you would have been correct. A negative negative would have been a positive, but a negative and a positive will produce a negative. Correct? And now we're going to add the exponents. A plus sign. My bad. I'll space out a little bit more. I was trying to get some more questions on one sheet. I was like, this is an equal sign. Uh, yeah, no, that's like a division sign bar looking thing. I got you. I got you. Yeah, that was part of, I was just underlining that as my answer. Yeah. Question it. Definitely question it. So I'm actually put the next one right here. I'm gonna give us some space. No, you're good. No, in my head, things make sense, but this is you are seeing this for the first time. See what y'all think about this one. Okay, when you say you're going to do the same thing, what does that mean? Okay, and you get perfect. I like that. So when you do the multiplying of your letters, you got to do them separate. So there's like an imaginary one there and imaginary one there. So that's a to the second power. Good catch, good catch. Because it's not AB together. That 3 is still only attached to the B, and this 4 is only attached to that B. So when I'm looking at A and A, that's A squared, and then B to the 3 and the 4. You would add those. Absolutely. Yes, and the reason so if 2 squared means 2 times 2, which is 4, 2 to the first power just means 2. That's why there's an imaginary 1. There's 1, 2 in that situation. So when I do 2 squared times 2, and I want to break that up, that's now 2 times 2 that would represent that. And then I have another 2. So then when I look at this, I'm going, oh, I now have 3 of them, which is then the same concept of just saying what's 2 plus 1. And no need to write it all out. We can just use some rules to make life simple. All right. Yep, that's the end. That's it. All right, so here's a new rule. Anything raised to the 0 is equal to 1. Just 1, straight up 1. No matter how big it is, it's still 1. You could have 5,372,018 raised to the 0. The answer is 1. You could have QBRT 17 raised to the 0. The answer is 1. It doesn't matter how big it is. If it's raised to 0, easiest problem in the world, answer is 1. So with that said, what is this answer? 1,587 raised to the 0 power. 1, done. Doesn't even matter what the number is. The moment the 0 on the exponent came up, the answer was 1. The whole thing is 1. Yep. All right. Now they do take this and they do try to trick you. So let's see how you do with this one. X to the 0 times X to the second power. Not that final answer won't be. Ooh, very good. Now, this right here, this is 1. And then this would just be x2. Now, I'm not imposed of having this as the right answer, because this is technically right. Your homework wants you to simplify it. Do I need the 1? No. So your final answer would actually be x squared. Now, here's something else I was hoping y'all would notice. This is still multiplying like bases. Just because we threw in a new rule doesn't mean I stop doing what I was just doing. What is 0 plus 2? It's 2. So if you still remember the original rules, I wouldn't even get to the 1 here. But that's what they're going to do. We introduce a new rule, and then you're like, oh, that's 1, and then the rest of it, and then that's where they get you. Okay. All right, so let's look at one more in this situation. Lots of problems today. Negative 17 raised to the 0. 1. Doesn't matter if it's a positive, a negative, letters, does not matter. If it's raised to 0, 1. Good? You'll want 15 of those questions on the test? All right. All right. So let's I tell you, when I saw the grades, I was like, all right, so now I got to start reflecting as a professor. Like, all right, what could we do better? So I'm hoping this next test, I'm hoping the fact that most likely this is probably your first math course you've ever been in. So the you probably just didn't know what to expect. And I hope, yeah. So I'm hoping that now you've seen the practice test, you saw the real test, and you're like, holy cow, these were so similar of tests. And knowing that the practice test you can take infinitely many times, I'm gonna limit pauses. So you do one or two questions and you come back to it, come do three and four more questions or whatever. Hopefully, knowing that when you take it during that Thanksgiving week or whatever day you decide to take it, you're like, I know it. I know exactly what's on the test. So the thing is all the homework will be due the Sunday before Thanksgiving. So that week you decide to take your test, all the homework for that will have already been done. So the only thing you would have to stress about is the test. Mhm. Yeah, we skipped. We Oh, chapter 9 and 10 was the beginning. So most likely, if you haven't like logged in, I don't think we did 11. We skipped 11. Yeah, we don't have 11 on there. Yeah, no, we skipped chapter 11 altogether. We didn't do systems. Are you doing like when you're going in? Did you have to solve systems? That was chapter 9. That was chapter 10. Chapter 11, you're like looking at intersections of systems and stuff like that, and that's not something we're covering in this course. That's something you'll see in college algebra. Yeah. Yeah, so yeah, go to like the due dates or current ones or something. Yeah. Yeah, let me know. And if you did some chapter 11, we can make something work. But I don't even know if you have the ability to go to a chapter I didn't assign. Yeah. Yeah, sounds good. Sounds good. We'll definitely look into it. Yeah. Yeah. Yeah, that's it. Yeah, you go down on the list I gave. So it looks like you're just it looks like you're doing exactly that. So you're just chapter 9, 10, 11 wouldn't have been there at all. Yeah. 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 Let me know. All right, so let's look at this kind of question, see what y'all come up with. X to the fifth divided by x to the third. What operation do we do here? Subtract. So if the bases are the same, just like before, it's still going to remain an x, but now I'm going to subtract subtract these two values. So 5 minus 3 would be 2. That'd be it. So when you're multiplying, you add the exponents. When you're dividing, you subtract the exponents. I have some corny hand movements if you like. When you're multiplying, you add, and when you divide, you subtract. High school kids eat it up. Add, divide, you subtract. Also, another way to see it is this little fraction bar. Looks like it's a giant minus bar too. So like 5 minus 3 as well. Whatever way you can remember the rules, you go with it. Didn't one of y'all say y'all are in A and P right now or about to do A and P? So A and P, there's a lot. When my wife took the course, there's a lot of like really corny things she used to help remember like all the bones and structure stuff. That's awesome. That's awesome. All right, see how y'all do with this one. Y to the seventh divided by y to the fourth. Mm-hmm. There it is. We good? They got one to try to trick you. So let's see how you do with this one. X to the fifth divided by X to the fifth. You would be absolutely correct. Here's two ways you can look at it. One, you're dividing by the exact same thing. So this is like 5 divided by 5. A second way to look at it, applying the rules. What is 5 minus 5? 0. What did we just learn? Anything to the 0 power is 1. Two ways to approach that. You can use the rules or just go, if I'm dividing by the exact same thing, the answer would be 1. No. If you put X, you're saying that 5 minus 5 equals 1. Because if you have an X left, you're saying you still got one X left, and that's not the case. I have 0 left, which I know anything to the 0 power is 1. Just 1. But I will say that is a misconception a lot of students will do is when something zeroes out, especially like if things cancel, if everything cancels, you'll always tell me the X is still there. I know you just told me they canceled. They're gone. It's gone. It's gone. Like there's only a 1 left as a placeholder. That's a great question. All right. Let's see where else. Okay. Got this. Number 5. Take an easy concept and it progressively gets a little harder. What's your approach with something like this? 12 x to the 12th divided by 4 x to the 4th. Very good, which is 3. And you subtract. So 12 and 4 give you 8. Very good. Here's the misconception students will make. They'll divide the 12 and 4, and they'll get the 3. And then they'll try to do 12 divided by 4 again and get a 3. Remember, with exponents, you're going to subtract. This would be 12 minus 4, which is 8. Watch out for that mistake. Because when you're in the groove of things, you're like, oh, this is division. And you're just dividing everything. And that does not apply to exponents. Coefficients, all day. Divide or multiply, as we saw earlier. That's how I teach it. So that's why I put a line here. Do coefficients. Then I'm going to do my x's because it's going to get more complicated. There's going to be y's and z's, and I'm just going to separate each one. I'm going to look at them as independent little bitty problems that I'm going to write the answer out as I go. Organize the information. All right, so let's see one. Where we at? So perfect example here. 21 x to the 8th, y to the 7th, divided by 3, x to the 2nd, y to the 3rd. Oh, that's just how the problem was given. Normally it is. They could try to trick you and rearrange the letters, but then you would want to write it so everything's lined up. Just like when we used to like add and subtract hundreds and thousands, we would line up all the place values. If it's not in the right order, just rearrange it so it is in the right order. But what I've seen on y'all's homework, it didn't try to trick y'all doing that. It did try to make the problems steadily harder as I went through the homework. And I was like, all right, so I got to make sure I bring all these in. But I didn't see any where they try to put any in order or out of order. Very good. There you go. Okay. Subtract. When you're so big in high school terms, big numbers do whatever operation is. So multiply or divide. Small numbers, this is where the rules will apply. You either add when you're multiplying or subtract when you're dividing. This one, that's a 3. Oh, 8 and 2. Yeah. Mhm. Perfect. There you go. That's it. And again, if you kind of separate it, you're almost doing 3 individual little problems to get the ultimate answer. Because really and truly, when you see this for the first time, you're gonna be like, that's a lot going on there. But if you just separate it by the big numbers, your X's, Y, Z's, Q, R, whatever letter they want to give you, just separate them like that. Alrighty. So I got a new rule for you. If you have a negative exponent, so like x raised to the negative 2 or something like that, this can be rewritten as a fraction. So if it has a negative exponent, I can write 1 over this exact same thing, but now we're going to make it positive. So a negative exponent is a different way to write a fraction. So for example, go away. For example, x to the negative second power would be 1 over x to the positive second power. So when you see negative exponents, mathematicians don't like fractions either. So we'll rewrite it so it doesn't look like a fraction, but that negative will tell us it is a fraction. So when we go back and do our work, it's like learning a new language, huh? All right, so let's see what we can do to apply. So this is number 6, I believe. 7 raised to the negative 1. What would that give you? Okay. Would I keep that 1? No. So will you take, you would change it and becomes a positive, but my question is, would you keep this 1? No, because it's imaginary. It's understood there's a 1 there. So you're not wrong by putting the 1 there, and I would count it right, but your homework says that's not simplified. No 1 is necessary because it's known that there's a 1 there. Yes. Yeah. So if you wanted to, you could say this and then rewrite it as, all right, I don't actually need the 1. Oh, it does? Oh, I love that. Gotta love that. Mm-hmm. I wonder if it was the wrong symbol or something. And that comes to a great question too, is like how much of the work are you supposed to put? And it's just the answer they want, not all the work prior to. So you might have typed all this in going, oh, here's all my work, and it's wrong because all they wanted was that last part. And that could be it too. Or a lot of times too, what I've seen is you get so used to solving for x that when you get your answer, you say x equals, and it's like a t or an r or something. It's the wrong letter, even though you did all the right work. So I know that's a lot. It can be frustrating as well. But anytime you ever get in a situation on your homework where it's like, I know I'm right, I just don't understand why it's counting wrong. Screenshot it. Let me see it because I'll be able to tell you, oh, you put this symbol. It's not needed. Or maybe you forgot a symbol, like a negative is usually the case. So, but yeah, just email me. I got you. I put on the policy 24 hours, but I'm usually quicker than that. So I do. I have many dates. Have I done some math work, took a picture, sent it to y'all, and kept on my conversation. I get a kick out of it. All right, try this one. X to the negative 7. What would that give you? Yep, perfect. Yep. 1 over x to the 7th. So it just becomes positive. That's it. This would be the answer. Yeah, yeah. This time it's an exponent. All right, see how you do with this one. Go ahead. So when you have a negative, it is a fraction. So that's where. So basically, this means that this is going to show up, and then when we put it to the bottom, it just becomes a positive. That's what the negative right there means. That's how I know it's a fraction. Yeah, that's just the rule. So anytime there's a negative, it's a fraction now. So it's going to be 1 over whatever this is, but positive. All right, so try this one. I'm curious what your approach is. X to the negative 11 times x to the 6. Oh, 11. So x to the negative 11 times x to the 6th. Ooh. Mm-hmm. But I think you were on the right track the first time. But you had the right idea. Okay, good. So multiplying like basis, I know I need to add these, which would be -5. But then we just learned a negative gives me what answer? What do I have to do though? There it is. So it becomes 1 over x to the 5th. I like that approach. That's the approach I would have taken. What I've also seen as an alternative way, completely up to you, some students will go ahead and make this a fraction. So they'll say this is 1 over x to the 11th times x to the 6th. And then they'll just go, all right, well, that's just one giant fraction. And so then they'll say 6 minus 11 to get to the -5. That gets us here too. I'm good either way. I like this method better. Mm-hmm. Yeah. But I think this approach makes the most sense. All right, so let's try to make this where we kind of combine all the rules we've seen so far. So let's try 3 to the -7 times 3 to the +10. Okay. Perfect. So -7 plus 10 be 3. Remember, you don't actually multiply the numbers. They stay a 3. Do watch out for that. But then, because this is a number, what is 3 to the 3rd power? 27. But by saying 9, most common answer, because you just want to go, oh, that's 3 times 3, but that's really 3 times 3 times 3. Third, they want 27. So when you're dealing with a number to a power, they want you to then to evaluate that number at the end after you do your rules. I do the exponents first and then figure out what the result is. Because if you try to do the numbers first, you're going to try to do 3 times 3. Now, in this case, there's a big difference from this versus this. Notice the 4 and the 5 do not have exponents, so I just straight up multiply those. But over here, the 3s have exponents, so they're almost as treated like an x, right? It's an x right here. You just carry it over, and then you can do the actual 3 times 3 times 3. Yeah. So well, go away. 27 is the answer. Yeah, that's it. Oh yeah. I got let's see. So oh, you're good. You're good. So we'll do another example over here. So let's do 2 -5 times 2. We'll go with 9. That's a good one. Take a moment. I will say one of the things we talked about when it comes to negative, think of money. You owe someone $5, you got $9. When you pay them back, how much money you still got? You have 4. Yeah. Now again, high school kids don't get that because they don't deal with cash no more. Everything's plastic. It's a tap. Yeah. So if you owe someone 5 and you have 9, when you pay them back, you still have $4 left. Yeah. So now what do I do? Mm-hmm. Mm-hmm. 16, which will be the final answer. But I will say the most common mistake is once you start kind of blending everything, that's me, sorry. Um, Students do try to multiply those numbers. So do watch out for that. Remember, the number stays the same and you're just adding the exponents. Okay. Try this one. X to the 5th over x to the -1. It is. Hmm. Let's think about this question. Did I convert that -11 to a positive first? I didn't. I just did what the rule stated. I added it first, got a negative, then converted. So my suggestion here would do the same thing. What operation do I do here? Good. 5 minus -1, and you get what? 5 minus -1. Mm-hmm. It is not. Mm-hmm. It's 6. So a minus a negative here actually produces a plus sign. So this becomes x to the 6th. And since the answer is positive, I don't have to worry about flipping anything. This is my answer. when you actually do the operation. So a minus a negative, you're actually really adding to the top. Correct. And you don't have to worry about flipping it because it's a positive exponent. You only have to flip it when we get a negative exponent. Let's see another one. 8 to the negative 4 over 8 to the negative 2. Exactly. Mm-hmm. That's it. Because these two negatives, once again, will produce a positive, so you do get a negative 2. This time, I got a negative answer. So what do I have to do with this? Perfect. But you're still not done. Because now, because now you got to do the 8. What is 8 to the second power? That would be 8 times 2. 8 times 8, so that'd be 64. But I will, again, that's a most common answer right there. No, it'd be 1 over 64.
Okay.
Yep, go ahead.
So, like on the 5 is positive.
Mm-hmm.
So basically you're adding.
Right. So when and if it helps, write it out. So this is 5 minus a negative 1. Then when you see a minus and negative next to each other, that means a positive. So in reality, this became 5 plus 1. So I did the same thing here. I wrote the negative 4 minus a negative 2, saw the 2 minus and negatives, said, oh, this is plus. So now the real question is, this is negative 4 plus 2. So you owe someone $4. You pay them back 2. You still owe them $2. And then since I got negative as an answer, I have to flip it to make it positive. But then because it's a number, I have to then evaluate what 8 squared is. So that was a lot of our stuff that we've done kind of all in one a little bit. There's definitely another one. Yeah, we got plenty. I assure you, I've had for this second, because once you understand this one, the rest of it looks more complicated, but it uses the same rules. So once we get these rules down, the rest of it hopefully is not as scary. So let's look at this one. I'll let y'all try this one. I know. It's hard not to be biased towards it. So x to the 7th minus the negative. Yeah, so anytime you end up in a minus negative situation, it's going to be a plus sign. That too, the calculator will come out correct as well, as long as you write a minus and a negative. Because if you don't, it'll just say minus. Yep.
So what did you say the first time?
Well, it's going to be a plus sign. Mm-hmm. So we have x to the 7th times y cubed over x to the 4th y 6th. Or explain it. I'm good either way. It is. Correct. Ooh, very good question. So in this case, remember I want to separate these as my x's and my y's, but when I do the subtraction rule, it has to be applied to the same term. So the X here would come from the 7 and the 4. That's a good question. Mm-hmm. Uh-huh. 3 minus 6 is in fact -3. Good catch. And I'm going to rewrite this one as 7 minus 4 so we can see why. So this is still not the correct answer. Mm-hmm. Can't have the negative exponent though. So what is the -3 being applied to? Just the y. So would I take the x to the bottom of a fraction?
No,
So the x to the 3 would remain where it's at because it's positive good to go. But this negative right here does need to turn into a fraction. But since there's already an x cubed, I can just put it on the bottom. I don't have to write 1 over that. Now, if you did, check this out. If you did say, oh, well, that just means 1 over y cubed, how do we multiply fractions? Straight across. So x cubed times 1 would be x cubed, and we can put a whole number, a fraction by putting it over 1, and then 1 times y cubed is y cubed. So what I try to say is if it's a negative exponent and there's something already there, I'm just going to put it on the bottom of that. And then I can get this result and bypass that part. But I will say that's what a lot of students do when they see the negative. They try to move everything to the bottom, but the x was already good. We didn't need to move him. Right? He had a positive exponent. No need. It was just the y. Another one? Absolutely. All right, here we go. 8x to the 9th times 3x to the 4th divided by 6x to the 16. A lot of stuff going here.
that's negative, right?
Yeah, sorry, that's a 8 as a coefficient. Oh, gotcha. No, that's 8 times x to the 9th power. I will say in this course here, we'll use this dot right here to indicate multiplication since there are so many x's so that we don't see an x in thing multiplication. I think that would be a good start. So 8 times 3 gives me 24. Carry my x over. Very good. Good. Perfect. That's a great start. Multiply the 8 and the 3, get it down to just one number, and go ahead and get the x to become one letter as well by adding the exponents. Now, we're not done yet. We're definitely not done yet. Mm-mm. Yes, you would divide the big numbers with the coefficients, 24 divided by 6. Actually divide that. Okay. Correct. There you go. Yeah. So yeah. So if you wanted to write that step out or realize that this -3 is only applied to the x, throw it to the bottom. So you do get 4 over x to the +3. But I'm good with that too. If you wanted to write it like that, 4 over 1 times 1 over x cubed, and then make it whatever. That's good. I'm good either way. All right, so I got a few more problems, and I think we'll take a little break. We good? All right, let's review some things. That's a weird 8. Let's try that again. What would this answer be? 5 to the -2nd. Mm-hmm. Perfect. So 1 over 25. Mm-hmm. It's still a fraction, but now it's 5 times 5, which gave me the 25. Yeah, so the first thing I do is get rid of this negative and make it a fraction first. I have no idea what 5 to the -2nd power is. But if I know that it makes a fraction, I do know what 5 to the 2nd power is. So then theoretically, I can say, all right, this is this. But no one jumps from here to here. Unless you can just, I mean, look at it and just, oh, okay, do it in your head. But most of us can't work out a negative. So we have to turn it into a positive, and then we can work that number out. Mm-hmm. Correct. Now it's positive. Perfect. All right. See how you do with this one. 17.06 raised to the 0 power. There it is. No matter if it's a decimal or a fraction or whatever it is, it's still going to be 1 because it's raised to the 0. All right. I'm going to show you one more, but it's really a calculator technique. Since calculators are allowed, if you were given something wonky like this, could I add these exponents? Could I? Is the question. Can I add the exponents? Yes or no? That's -4.7 squared and 1.2 cubed. Can I add those exponents?
Yes.
What has? Correct. So this is a question on your homework. They're going to try to get you with this. Since this is not the same as this, I cannot add those exponents. So when you end up, go ahead. -4.7 and 1.2 are not the same number. So here, notice this was a 3 and a 3. This is an 8 and an 8, x and an x. Oh no, it doesn't have to be negative exactly. It's just the fact that -4.7 is not the same number as 1.2. So I could have said +4.7, but I still wouldn't be able to add these exponents because 4.7 and 1.2 are not the same number. Okay, let's do this. Y squared times x cubed. Can I add those exponents? Yeah, the little ones, the little powers, exponents, whatever you want to call them. I can't add these either because this is not the same letter as this. For you to apply the exponent rules, the base has to be the same. So since these aren't the same number, can't add them. Since these aren't the same letters, can't add them. No, there is a way to do it. I'm about to show you. But I wanted to make sure that y'all didn't, because here's the thing. Let's go here. Let's say that we can add them, right? We know that's going to be 5. What number are you going to put there? Would you choose the negative 4.7 or the 1.2? Right? You shouldn't have to make a choice because they're not the same. So we can't add those. So I know there's a homework question like that. I think it's more like this one, but you're just going to try to go, hey, what's this answer? And hopefully you type the exact same thing right back. Because the answer to this question is the exact same thing. There is nothing you can do here. This one, a little different. This one I can type into a calculator. So I would go parentheses, negative 4.7, close parentheses, squared, parentheses, 1.2, oh, 0.2, close parentheses, rooftop, cube, or 3, and there's my answer. So in a situation where you can't use your rules, you can just plug it into the calculator. Now, with that said, anything that's just straight up numbers, you could technically just type in your calculator and give you the answer. So let's take one of the examples that we had earlier. Where's that? Heck, let's take this one right here. 5 to the negative second. I can go 5 raised to the negative second. And I am okay with that. But you still need to know the rules because if it's letters, can't type letters in a calculator. So you have to still know the rules. But if you are doing something that's just straight up numbers, you could technically just plug it into the calculator. Oh, arrow away. So I hit this little arrow button. Yeah, that's like a little doggle, I think is what it's called. Mm-hmm. Okay. Where was I just at? That would be something like this one, where the first thing we did is add those exponents, and then we subtracted those exponents. So that's what you would want to do on yours.
So we would, but it would
I wouldn't until the very end. I don't convert fractions until it's my final answer. I don't want to have to deal with fractions in the middle of it. So for your example, so I would first add these two up, just like we did in that last problem. And yeah, you would get x to the 15 over x to the negative 1. Then what would I do with these exponents? So this becomes x 15 minus negative 1, which will give you, that gives you a positive, perfect. There it is. So that's my approach. To get the top down to just one letter and then do the division part. All right. So we'll take a 5-minute break. We'll come back at 7:14